Rainbow. Rainbows are one of the most beautiful things on Earth, containing a spread of the colors that our eyes can see. That's why we use the expression, every color of the rainbow. But did you know this expression isn't technically true, that the rainbow is actually missing a few colors? If you could look extremely closely at a rainbow and analyze its light, you would find dark gaps in the otherwise continuous spectrum of light. This is because pure white light can be shined through a prism and split into every color our eyes can see. But the sun doesn't send us pure white light, it sends us an atomic spectrum. An atomic spectrum is a spectrum that has been shined through or originates from a material, usually a gas, and contains patterns that are characteristic of the elements present in the material. When we analyze the sun's spectrum, for example, we can figure out what elements are present in the sun. To analyze the sun's light, we shine it through a spectrometer, which is a device that separates light by energy and color. When we do that, we create an image of the sun's spectrum that looks like this. An absorption spectrum similar to the sun. The black lines show where light is absorbed by the elements in the outer layers of the sun. Red light is the lowest energy and blue light is the highest energy. Just like how a red ember on a fire is not as hot as a yellow flame, and blue flames are the hottest of all. The black bars, the gaps in the sun's spectrum, are known as absorption lines, and they're caused by the gases in the outer layers of the sun absorbing some of the light. The sun contains many elements: hydrogen, helium, carbon, and smaller amounts of heavy elements. When the light from the sun shines through these elements, the atoms absorb the energy, but they only absorb light that is just the right color to match the energy they need. This gives us those gaps in the sun's spectrum, and by looking at the gaps, we can see what the sun is made of. An emission spectrum is the opposite of an absorption spectrum. Instead of getting light with a few colors missing, in an emission spectrum, those are the only colors we get. To create an absorption spectrum, we had to shine light through a gas, but to create an emission spectrum, we heat up a gas instead. The atoms in the gas will absorb this energy, but only for a little while. Heating the gas causes the atoms to be jiggled up and energetic. They have too much energy. Eventually, this energy is re-released or emitted as light, and the color of the light that is emitted is different for every element. So we can look at the emission spectrum of any given gas to figure out what elements are in the gas we're heating. So far, we've learned about how atoms can absorb the light of particular colors, or when heated up, emit light of those same colors. But how does it do that, and why is it only certain colors? Atoms contain electrons orbiting around the nucleus, and those electrons sit inside energy levels, also known as shells. Energy levels are particular orbits or particular amounts of energy that electrons are allowed to have. Some examples are shown here. As you can see, we can draw them as circular orbits, like on the right, or represent them as straight lines, like floors of a hotel, like on the left. The electrons in an atom can absorb energy and jump from a lower energy level to a higher one, but only if they get exactly the right amount of energy to make the jump. If they jump too far or not far enough, they'll miss. And if they're going to miss, then they stay where they are. As you can see in this image, atoms can only absorb light of certain energies or colors. The straight arrows show electrons jumping to higher energy levels. When you shine light through a gas, the electrons absorb light that has enough energy to help them jump up. This gives you the absorption spectrum, with particular colors of light absorbed. And when you heat up a gas, the electrons also jump up, before later falling back down and releasing this energy as light. This gives you the emission spectra, which contains certain colors of light. The colors match the atom's energy levels. In this lesson, we've discussed two types of atomic spectra: emission spectra and absorption spectra. Absorption spectra are what you get when you shine white light through a gas. Certain colors or energies of light are absorbed by the gas, causing black bars or gaps to appear in the spectrum. This happens because the electrons in the atom of gas can only absorb certain amounts of energy, the amount needed to jump up into a higher orbit or energy level. So light that has this energy is absorbed, and the rest of the light passes through. Emission spectra are what you get when you heat up a gas. The electrons in the atoms absorb the heat energy, allowing them to jump into higher energy levels. After a while, the electrons fall back down into lower levels, and the energy they lose in the process is released as light. The light that is emitted matches the energy levels of the atoms, and so has particular colors. Because every atom has different energy levels, every atom will produce different absorption and emission spectra. We can use absorption spectra and emission spectra to find out what elements are present in the gas, including the elements present in the Sun.